Okie dokie. Bum, bum, bum. Okay, if anyone is watching, then just let me know if the audio is okay. So last time we just tried to check Alex's Filipinas demo, and we were missing that top LED segment, and that was actually due to a missing resistor on the board I just found. Hi, Alex. So yeah, we're going to try your design. Hello, Dusty Circuit. There you go. Select. Reset. Clock once. Does the reset do SA? Okay, so let's just go back to here. So this is the message. Let me just present my screen as well. Filipinas, La Salle. So I'm going to clock this one clock at a time, and we should be able to see that. Let me just move to my, there we go. So go back to interact. Okay, here we go. PILIPENAS, La Salle. So there you go, Alex, working on silicon. Congratulations. I think I've already reported the results. Yeah. Yes, the top segment was a missing resistor on the board. There we go. And here's Pat.
Oh, ho, ho. How's it going?
We need a little noise on the ads. Yes. Okay, so it's just it was actually not that solder. It was a missing resistor.
Oh,
the resistor on segment 0 just wasn't on that board, so that LED never lit.
Failed to keep my QA there.
God damn it.
God damn it. It was crunch time.
Yeah. So was that was one of the, is the Filipinas one of the ones I was going to do? Oh, we've done this one. Yes. Okay, and then so I've got Pat's on the stream to help us take a look at the SDK. And I don't know, like, how realistic you think this is, Pat, but there's a couple of SPI projects on there. Can we drive SPI like relatively easily?
Relatively easily. No.
Like, no.
There's no built-in method of saying this is SPI and let's go. As far as I know, we have access to the UI in and and we can do that. But there's nothing built in that we can just say send SPI over there, which is actually a good idea. I think that would be pretty nice, but don't have it yet.
Yeah. Okay. There's maybe a couple more on here we can just take a look at before we move on to the Cocotb stuff. Let's have a look at my my classic RGB mixer. So we should just get 3 PWM channels coming out on that.
As soon as you activate?
Yes. And set the clock. I think this works better at a slower clock frequency. Okay, yeah, I can see on the 3 illuminated LEDs there. I tried to get the I get the scope connected again. And we just check channel 0 and channel 1.
Oh, the first is the top segment?
Yes, so it's on weaker than the other two at the moment.
Is that because you put in a resistor?
No, I swapped to a different board because you sent me 2.
Oh, hooray. Hooray for redundancy.
Exactly.
Just wondering why it's weaker, though.
Maybe I need to reset the... It could also be because the inputs are floating.
Are they? Oh, you're not in interact mode. Okay, okay. Yeah, they're floating. No, they're not floating. They should be pulled down.
Okay, well then resetting it should resolve that. So let's turn on channel 1 as well and auto scale.
What are we viewing? I just see the connectors on the scope. There we go.
How's that? Is that better?
Yeah, but that signal. What's on channel 2?
There we go. I think I forgot to solder on those connectors, which would have been a good idea. So it's just, oh, maybe it's because this ground isn't connected. There we go.
Yeah.
Okay.
There's some pretty bad glare in the screen.
Yeah. Yeah, can't do anything about that, unfortunately. Spent enough time trying previously. So now, if I reset it then, there we go, both down to 0. And then by playing around with these things, I need to set that to be momentary. This doesn't look like it's doing anything, does it?
What's the dash 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 on the bottom? Do we have a channel 3 there?
Dash 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 on the... Oh, no, that's... I can...
Oh, okay, okay. It's the times, but they're a little smushed.
Yeah. Yeah. Let me take a look at the pinout. Encoder 0B. Okay, so yeah, clicking those should start the PWM running. Is the clock running? Oh, for some reason the clock's back here set. That's interesting. So I've not noticed that before. I think one problem is that we're kind of road testing this new commander. Every time I go back here, it's changing the clock, but I guess that's not actually...
Set clock? Yeah, I don't think it actually changed it.
No.
No, now we see.
Yeah, so I had to...
Oh, it was the UI. Yeah, it's that toggle.
Unclick and click it.
Yeah, it's not reflecting.
Let me do a couple on this one as well. There we go. Now we got trigger lock. Trigger lock. Maybe make my shared desktop zone larger in the stream. Shared desktop. I don't, Sylvan, you mean you want to see this window bigger? Larger in the stream. Like that.
Didn't have a huge impact. Why do we
that's
have...
kind of cool though, like being able to do it like that.
What are you doing?
Maybe it doesn't happen until I press save. But I managed to get the scope like more bigger.
More bigger. Okay, but now the UI is a little more smaller.
Yes, but I can maybe...
You can switch around depending on... Oh, yes. Not sure we need the big debug on the... Anyways, so...
Anyway, you should be able to see as I'm clicking on here now, we're getting the longer and longer PWM cycle.
So it's counting what you set into the inputs.
Yeah, if I had the rotary encoder connected, then turning it one way would increase it and turning it the other way would increase it. But I'm not sure if I have an easy way of...
You'd have to do the right A-B sequence, right?
I have to do the right sequence to make it...
You got it.
Yeah, it's just more annoying. Is that something that we could easily do in the REPL?
Oh, yeah, in the REPL.
Yeah.
Yeah, I mean, yes. Just create a function that says forward, backwards, and then toggle in the right direction.
Come on, show me how to do it then. Let's try to first. Let's just try to do this. Just do that so we get a slowly increasing thing. That'll be a good start. So that's like a TT UI in dot value.
Sure, you could do that. Yes, but
you tell me.
Pardon?
You tell me.
Oh well, we only care about the first bit, right? Bit 0. So you can index it. So dot value index 0 or UI in index 0.
That is
no, I mean square bracket 0.
Okay. Like that.
Yes. Equals 1 equals 0, right? So you can just...
Is it here or is it on the dot value?
It's actually both.
Okay.
Yeah. So if you just press enter there, you'll see whatever it is, but you can go 0 1 0 1. Is that working?
Doesn't look like it. Do I need to kind of set the pi?
Oh, wait. Are you you're in manual mode, right?
Yeah, do I need to have this clicked on again?
Yes.
Here we go.
Is that okay?
Yeah,
it's working.
Yeah.
Okay, so yeah, you could create a function.
Now I can do a for loop.
Yeah.
Or a while true.
Or while true.
Zero. 1.
You broke out of it somehow.
Yeah.
Do you not have history?
How do I actually start?
Just backspace and then enter.
Ah, yes, look at that.
There you go. Woo! Oh, okay, and it overflows. That's great.
Cool. Elite programming skills. All right, sweet. Let me just make a note then. Oh, well, let me go back and check the third output just so that I know. So I need to give a little button click on here. First, second, third. There we go.
You're not mom?
Not mommed. No, I'm mommed.
There you go.
Yeah, cool. Okay, so all three
Actually,
channels.
why do you need the mom? Because you're going 0, 1, 0, 1. What's the mom thing about?
It means I can go twice as fast.
Oh, I see.
Yes. Checked all three channels. One thing I was forgetting to do earlier was to stamp the datasheet.
You're stamping when it's tested?
Yeah, I got a stamp.
Nice. Oh, the pro kind. Chonk.
Yeah. So what number am I? 76. Oh, and I've got the Filipinas here as well. Here you go, Alex. Here's one for you. Does the sound come through on the stream?
No.
No, that's a shame. It's a great sound.
Oh, we got the sound. Yeah. I thought
okay.
you meant visually. Cha-chonk.
Approved. Approved. And one for Filipinas. Well done,
Nice.
Alex. Okay, so one I wanted to try that I thought you might like as well was this FIR filter.
Neat. It's a little smallish. I can't really read this. Here we go. Input. Okay, so you're sending digital data, whatever, the stream of inputs.
Yeah.
And then additional output. So the setting is the 2 last bits of the bidirectional? Like how big the window is?
We can provide a series of digital inputs to the UI and observe the smoothed output on UO out. I guess I'm not, when I see the word strobe, it makes me think it's not going to do anything without strobe going high, and it's not, doesn't say anywhere what the strobe does in this documentation.
Does it have a test? What I don't get is strobe output. It's like you set your input bits and then you say, yeah, okay, it's good, puff. But then...
Yeah, it has no test, I'm afraid.
Wait for strobe.
Okay, I think this is not enough documentation. No stamp for them.
No stamp for you.
Not good enough for me to test it on a stream with that, I'm afraid. So how about the we're going to try the Cocotb thing.
Yeah, you want to do it on your RGB, and do you want to type it out, or how do you want to do it?
Yeah, so we've got the it does have a. Okay, I didn't even see that, Sylvan. When I checked it, it just looked like the default test. So, oh no, wrong one. Source test. So this is the test bench for the RGB mixer.
Okay, cool. And you have another file there included.
Yeah. And actually, just like one of the things that Sylvan said was that because the test on that other one, the moving average filter, depends on internal signals, it wouldn't wouldn't be able to run it
Oh yeah,
easily.
no. You can only play with the black box.
Yeah.
So in this
But
case,
what I've got here is I've got a debug mode. So when
Yep.
the debug mode is enabled, the output, the internal state of the design is output onto the pins.
But that's what happens. And all you're playing with in your test is I/O, right?
No, because with this one, if you set the debug port, the internal value of the encoder is put on the bidirectional pins.
But okay, so and that debug thing isn't coming in through the pins.
We set that with these 2 bits in the input.
Oh, okay. Well, we can do that. That's fine.
Yeah. So this is the test bench that should hopefully still work.
Okay, yeah.
Let's check that first.
It's not in your history because of that space.
Exactly. Yeah. I guess it's, if you know you don't want it in your history, it's a good way of preventing it.
Okay. Yeah. I don't think that's ever happened to me.
Okay, that's
great
news. The old Cocotb issues, the everlasting Cocotb issues. What is it this time? Cannot run. It's the wrong
it's the version.
Yeah.
Just no, but if you make clean, you'll get rid of whatever's there, and your new version will be built. Because you're probably up to version 12 or something.
There we go. Yeah, good job.
There you go.
Okay.
Hooray.
So you see the PWM outs. But yeah, we also get these the bidirectional outputs are showing the internal counts. So if I load up the actual value here, these 2 are the same.
Right.
But normally you wouldn't have access to them, but that's what the debug mode is for, and that's what that's why I'm telling people that they should think about design for test, so that if something doesn't work, you can always come back to it. Okay, so what do we do then to try to adapt this for?
Your 2 files.
I want to just read what Sylvan's saying. He thinks our test is not going to will run as is because we rename the signals in tb.v and use those renamed signals in the test code.
Yeah, there's support for that.
Okay. All right.
So okay. Get your files and into a place where you can edit them and change them up a little bit, because we're going to add.
Yeah, here we go.
So are you making copies or something, or you're going to edit them there?
I'm in a Git repo, so I can.
Okay. So let's check the encoder that's included just to make sure there. Okay, so first thing, we have a local version of Cocotb. So rename that from Cocotb, just change that to from micro-cotb.
Okay.
Just one co though.
Micro-cotb.
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 Okay. Otherwise, I think this one is good. Let's just scroll down and make sure. So you're passing all these things, blah, blah, blah. You've got asyncs. Okay, so, but you're passing these signals in or something like that from there. So just save that.
So just to make it clear, what we're trying to do here is I've got a test bench that I developed for helping me write the RTL and checking it's correct. But now you saw what we had to do with like pressing that button to like get the PWM signals to change. I'm not doing a very good coverage on the test. My test bench here has got better coverage than what I just did on the real hardware. Wouldn't it be great if I could take my test bench and then run it on the hardware? That's the idea.
It would be great. So, hardware in the loop magic.
Hardware in the loop, Cocotb,
So yeah, just import micro Cocotb as Cocotb there, just so we have less stuff to change.
Yeah.
And get rid of one of those co's in micro Cocotb.
Okay.
And then replace the Cocotbs in the following lines by micro Cocotb.
Like that.
Yeah. Okay. So the rest should work, but we have to add in a little bit of extra stuff in the end to create the runner and
okay.
And map these names these beautiful names that you have there into something that actually will work, because all the default DUT knows is the UI in, UO out, and stuff like that.
So that's the mapping that I've done in my testbench.v.
Yes. So we need to redo that. So what you're going to do is go into your testbench file, your test py file, create some function, main or something like that.
Like how do you do that?
No, I mean just def main. Yeah. So in this, we're going to run the test. So first off, we have a DUT. So import ttboard.cocotb.dut. That's the default DUT. It would dot cocotb dot DUT.
Mm-hmm.
Yeah. Oh, and I think maybe at the top I made a mistake, and it has to be import. No, I was wrong. But that space there is bad. Okay, all good. Back to the main. So now we need a class to wrap the default DUT that's in there into something that will map your names. So create a class DUT and derive it from ttboard cocotb.dut.capital.dut.
Spell it out for me.
The import we just did.
Mm-hmm.
So ttboard cocotb.dut dot big D, big U, big T. Another DUT there before because we imported.
Yeah.
Dot capital DUT.
Okay. All in
okay. So now and now colon start the class.
Okay.
So def init self. You need the underscores there.
Okay.
Def underscore init. So now we're going to we super do the super call. Super parenthesis dot underscore init underscore. And you can give it no, don't pass it to self. The super does that job. Give it a name. You can call it the RGB mixer or whatever in a string. And so just give it a string, and that way when it logs, it'll have that name. So now we need to create these things, and so to know what we already have a clock, we already have reset n, but you need to map all these ports, right? The ENC 0B or whatever it is. I don't know what those are, so just tell me what to map. Let's see. We've got something that is PWM out 2. That's out 2, right?
There we go. I think that's everything.
It's not everything. There's other PWM outs, isn't there?
Oh, yeah, I managed to miss them.
Okay,
and then
good.
This is the mapping of UI in. And we probably have the BIDA as well, don't we? There we go.
Oh, it's just mapped straight up?
Yeah.
Okay, so what we can do for the UIO out stuff is just rename this attribute, right? Do self dot debugenc equals self.uio_out. So that one's handled uio out.
Okay.
And that's it. Now for these other ones. So we have a couple of different cases. Some are just bits and some are actual slices, right? Like debug mode has more than one bit.
Yes.
So we have two utility methods in here to create these. So for each one, let's say self-debug mode, go self.debugmode equals, and then self new, what is it? Give me a second. I need to find this. Cocotb, where are you? That. Okay, so we have two helper functions here, new slice attribute and new bit attribute. So this one is a slice, right? So say new underscore slice underscore attribute. And then where's this come from? It's the UI in, right? Yes, it is. I mean, it's being assigned to UI in.
It's 7 and 6. Yeah.
Okay, good. So so go, what is it? Self.uin, yes. And then the bit index, I think 7 and then 6. No, not like that. Just comma 7, comma 6. Just the indexes. So self UIN, comma 7, comma 6. Yeah.
Without the square brackets, or
without? Yeah, just a comma.
Okay.
That's it. So that's that one, and then same for every other slice. For bits, there's a different method, and it's new bit attribute, and that's it. So you can get what we're doing. For each one, find where the source is. Is it UI in? Is it UO out? Blah blah blah, and then specify the indices.
Yeah, all of these ones are going to just be that's like inc2b equals
self new bit attribute, and then the same parameters but only one index.
And that's going to be
5, I guess.
Yeah.
Okay, so now we have all our attributes. There's one other thing, though. You're using the bidirectionals as outputs, right? Okay, so we don't actually have to do anything because they'll default to inputs, but you might have to play with that if you were doing another kind of test where you played with the output enables.
Yeah. So that's it just asserts that the debug inc is what we counted up to.
Okay. That's fine with me. You need to get rid of those assigns that are still hanging around down there. And then we need to do outside of the class.
Yeah.
You want to create an instance of this dut object. And I think, yeah, maybe rename that class or something, because I like to call dut, but whatever.
What should I rename it to?
I name it capital dut.
Okay. Oops. Like that.
Yeah, and then I just do little dut equals class dut instance construct dut construct. Yeah.
Mm-hmm.
All right. Now, runner equals Cocotb dot get underscore runner. And then runner, parenthesis, call that function. And then runner dot test, parenthesis dot. It's a parameter. Yeah.
Mm-hmm.
That's it. If we put these two files on there and then call this main function,
I think it's gonna get stuck with not knowing what PWM0 is, right? We're gonna have to do another.
Oh, hold on. Yeah. Those are more parameters. I forgot about them. There you go.
And then the other one is it's going to be looking for the debug enc. Oh no, we've already assigned that here.
Yeah.
Okay. All right.
So I don't know, but let's stick those on to the Pi and
see where it crashes and burns.
Yeah, that's it.
Okay, so np remote cp test.py. I think it's A3.
What's that? I see.
ACM5, which doesn't work. That's one of the nice things about np remote is it only does up to 3. Otherwise, you have to provide it with something else. So I can never remember.
Did you try turning it on and off again?
Connect.
I use R shell.
I know.
Which is annoying in its own way.
Okay, that's all right though. CP test. There we go. And then we need the encoder.
Yeah.
And that was it, wasn't it?
That was it. We need to connect to the shell now, to the REPL.
Okay.
And restart this thing by control. Actually, you might not need to reboot it, but whatever. That's fine.
And we're going to need to also select the project as well, aren't we?
Oh, yeah, that's right. I forgot about that. that I usually put in the main as well. But anyways, you can do it manually now. So that would just be, the usual.
I'd like to be able to tab complete this because I can't remember the name.
It used to work. I don't know what broke. But the tab completes are now unhappy. It has to do maybe with the lazy loader, but it's a pain in the butt. It'll work once it's loaded, which is useless.
Okay.
All right. So from, what was it? Test, import main, and then main.
Bam!
Boo! Indents. What is this?
That's all spaces. That should be fine.
White spaces. What a nightmare.
Is there? Can you remember how you get Python instead of to run, just to check syntax?
I don't remember.
I've got the same thing.
I would try -C for by default, but let's see.
I do have something wrong there. Okay, great. So let's copy that across again then.
Oh, we should have added the shuttle blah blah blah.
Yeah. Okay. tt.shuttle.ttum mixer.
Oh, but you know the index. You can do shuttle square bracket index 76 or whatever. Yeah, it's 76. You can do shuttle 76 enable.
Like that?
Yeah.
Okay, let's grab that for next time. Okay, from
test import main crash.
Oh, wow, okay, imported. Cool.
That's nice. That's nice. Okay, let's see what the bigger problem is.
Yeah, I'm just looking at the scope as well, and we've got some high frequency. Oh, it's maybe not high frequency. It's just not triggering on that number. It's triggering on number 1, not number 2.
So
we should reset it as well. How do I reset it?
Oh, it's not done in your tests?
Well, I haven't started it. Let me just.
Right, but you can reset it with reset project true. It'll be in reset until you say false.
Okay. Yeah. Yeah, because I do that reset.
Okay, so it'll reset when we run the test.
Yeah, I just wanted to start with this, like knowing what was happening on the scope. It's already started.
But what is happening? Why does it run when we've reset?
Don't know.
And that reset didn't seem to do anything.
No, it did. Yeah, I don't know. It's like it's getting a value happening on one of the inputs, and that's starting the PWM. Anyway, let's see what blows up when we.
Yeah.
So now we do test.main.
You imported main, so you can run it without the test.
From test import main. Okay, so I can just do main.
Yeah.
All right.
Romp. Local variable reference before assignment 86. That's weird. Dut equals dut.
Oh, I'm inside the class here.
Probably we are inside the class. That's not good. Yeah, do the load right.
Yeah. Okay.
Cool. Copy that over and.
Oops. Can I see? Get over here.
When I'm doing this stuff, I usually do the import inside of main, so I don't have to do it every damn time I restart.
Okay. TT isn't defined on line 70.
Oh, yeah. Okay, so go down to line 70. Yeah. From tt.board import demo board.
Anywhere.
Anywhere, really. You could do a global scope, but anyways, from tt.board import demo big B board. So sorry, big D as well. Give him the big D. Okay, and TT equals demo board dot get parenthesis. All right. So that gets the singleton, and we're all set. Come on.
Damn.
Oh, come on. No module. What?
Did it actually copy it over there?
No, the error is different.
Oh, is it? Okay.
I think. Anyways, hold on.
Line 70. Oh, yeah. Yeah, well, we don't have a TT, so how do we...
What am I saying? It's TT board.
Ah, like this.
Yes. TT board dot demo board import demo board. Wow. I haven't done this a million times.
It's as easy as this, everybody. Just develop your own... after you've done the hard work of your silicon design and waited a year for your chips to come back, it's just as simple as this.
Just as simple as this. Okay, this might actually work.
Come on, I sense a full hour of hacking ahead of us, Pat. So we've got a hard stop at 6. Well, Docs Motion Studio is saying Python is a pain, but in case it wasn't clear, I was joking earlier. But actually, I think, we're testing new stuff here with like new changes in the SDK. So like, definitely, I'm not familiar with it.
Oh, yeah.
But the whole point of using Cocotb for doing testing is it's actually a lot easier writing test benches in Python than it is in Verilog, I think. From main, from test, import main. Okay, look at that.
Oh, wow.
It got somewhere.
Yeah, but we didn't define this name right, apparently. PWM0 out _out. That's what they're called. Yeah.
There we go, yeah. Blasphemy.
I kind of wish that we wrote the history to the REPL. It's really annoying having to read.
Yes. At least with this, it's like, I mean, I could run this all from the command line, actually. I guess I don't need to try that next time.
Now what?
Okay, well, that's actually something happening, isn't it?
Yeah, which line? 45, test all.
PWM should all be low to start with. I can actually see that they're low on the scope now, though.
Oh, what is this? Oh, you're using Cocotb, not version 2. That's what this is. So the all these dot whatevers should have a dot value.
Oh my God, this is like a really old test bench. Look, these ones do have them.
Yeah, so I think you should. Yeah, just grep dot and grep v value and see which ones don't have them.
Yeah. Okay. Well, I won't grep, but I'll.
That's good. Who knows what happens in encoder, though?
Okay. Yeah, because do we pass in the dot here? We must do.
Self.
And those ones are set to be value.
Okay.
Yeah. This one is just generating like noisy encoder signals anyway.
Okay. So let's try this. Woo. Well, at least the onboard Cocotb thing is working. So that's cool.
Let's try. Can I do something like from test import main here?
I don't know.
No.
Sadness. But you could change it. You could change main and put that in, get it, edit it. Also, you could just import test and then do test.main, which might be less typing.
Oh, I just saw something on the scope there momentarily. Should I be able to see these signals on the input pins?
Yes.
We're expecting this to run much slower, aren't we?
Yeah, like, yes, we are. Short version.
Okay. I can see that LED like flashing on the...
Right, because every time, I'm not even sure. I haven't checked what the tests actually do. Is there a chance we could hang here? Because you could set a timeout on the Cocotb testing, but
Oh, look at that! These are the signals coming into the encoder being generated by the test bench.
Mm-hmm.
You see the noisy edges?
Are they noisy?
Well, they're
The
being.
clock
I mean,
is
they're
super
being
jittery.
Yeah, they're being like jittery, but that's like intentional. That's like to test the debouncing.
Oh. Well, oh no, but the debouncing, oh, I guess that would work because the clock is slowed down as much as all the rest. So
Yes. Why don't we? Yeah. How do we check the clock?
the pin is in the front there between the P mods.
Okay.
There's a clock and a reset and a buy. On this board, it's under the input button, but I can't remember. But it should be, it's in the sill, you know, where the P mods are. There's also a sill version of everything.
Yeah. I just can't read it without my glasses on.
It should be the first on the left of the 3 pins that are next to input.
In 3, in 2, in 1, in 0, 3 volts. Oh yeah, I got it. Clock. Okay.
Okay, so there's the clock.
Yeah. All right. Wow, that is so slow.
That is so slow. How long is this test? What does it do?
It runs through all the PWM values on all 3 encoders.
But is it doing an assert at each point there? I guess so. So we're passing is what this says.
It's it's clocking itself up all the way up to the top. One thing I could look at is what's happening on the bidirectional pins.
Yeah.
Because that should give me the output from the
you could just log it in the test, but yeah.
Yeah, log it in the test as well. Okay, yeah. So that's counting.
Which pin are we on? Like
Bidirectional 0 and 1. So it's the 2 least significant bits.
So it's going slow. I actually managed to test my SHA-256 encoder on Tiny Tape Out 5.
Yeah.
It's not super fast, but it works. So
yeah,
the magic of the digital, even though the clock is like super jittery, it all latches at the right time. So
okay. Yes, it's getting there. It's counting. It's still on that first channel.
Goddamn.
And there's 2 more channels to go, so I think we'll probably interrupt this. But that was cool. That wasn't too bad getting that test bench to work. I can leave it running when I leave and see if it gets to the end.
It should. And the thing is, with the test bench, if your tests only use UI in, UO out, blah, 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 then it's a lot simpler. You just get that DUT and don't derive from it and use it as is.
Yeah.
So there's really nothing to do. It's just when you need to adapt the DUT to use these internal names that you have to do all this putzing around.
Yes. So if I didn't have any of that, would I just need to do this, or do I still need to create the class?
You don't need to create the class. You just need to create an instance of TTBoard Cocotb dot. So you don't derive, you just get an instance straight up, and it has the UI in, UO out, and all that stuff. So that's pretty cool, and you can await on the timer the clock cycles, the rising edge, the falling edge, most of the stuff most people use.
Cool.
Oh, and by having the import of the stuff inside of main, you can actually reuse this exact file for both Cocotb and on the hardware.
I think I just messed that up, didn't I? I meant to do that. There we go.
But give it a shot. Try make in the desktop with these files.
Yeah.
Oh no, we changed the imports at the top. Never mind.
Yeah. Yeah. Okay. Where is my
mind?
It got destroyed by making too many ASICs. Where is the there it is.
There it is. What else we trying?
So that's this one. Let me just check what happened when I pushed there. Yeah, okay. So if anyone's interested in seeing the changes we made, I pushed that branch.
There are examples now in the SDK with a lot of functionality.
Yeah.
In source examples, I think.
Oakley dokley. So we've got 15 minutes left. Any requests from the audience? Any requests?
Any requests? Someone asked clock.value. I'm not sure what the question is, but the clock that's provided in the default dot acts like any Cocotb thing. So yes, it does have a dot value because it's just a 1-bit signal like every other.
Let's try this dice one, because I thought this one had a very nice, but wait, there's more. Good documentation. You see the, tell me guide me in with positioning to see the 7 segment.
Yeah, we see it, but we only see half the board, the bottom half. So, whoops, now we only see the probes. Good. That's pretty good.
Yeah.
We're a little far away, but it works.
Oh, the tester's moved on to the second.
Oh, can I see the screen? So we've passed. How many tests are there?
We've passed. Well, yeah, I could print out a bit more debugging information, I guess. So I'll kill this.
Oh, to the second PWM is what you mean?
Second PWM channel, yeah. And
okay,
I guess if we were really patient, we would see that segment getting slowly brighter and brighter.
Would it though? Because it's PWM'd at the rate of the clock.
Ah, yeah, you're right. Yeah, which is extremely slow.
Yeah.
Okay, so let's kill this then. and go back to the commander. And this one is called Die Roller by Nathan Gross, or Gross. Don't know how to pronounce her name. Oh no. Oh, I chose a different one.
It's a nice weird C thing, though.
Die Roller. Dice. Maybe I'll come back to this one. Yes, the I2C peripheral is different. We don't actually need that. Select. That's the, but wait, there's more. Only used a third of the area, so he decided to pack a simple I2C slave in there as well.
Okay. Got the space.
The space. So, how to test. Configure 7.5 for the appropriate signal polarity. Demo board should be set to 7.6.0.1. 0 and 1.
What? Was this the...
It's saying here that because it can drive like a two segments.
Right, but this is UIO.
Oh yeah. Oh yeah. So actually, that's not something I can do on the commander, is it?
Through the REPL.
Through the REPL, exactly. Okay. And then push one of the buttons. Let's just see what happens when we push one of the buttons. Rolls a 4, 5, 6. Rolls a D100. Okay, so turn that one off. Momentary. Do I need to reset it?
We need to clock it.
Isn't it being clocked? Or I need to set it.
Yeah.
Oh, now it's doing something different, is it? Reset. No, it's showing an 8 and a dot. It's probably because I've got the thing set up wrong.
Oh, the UIO stuff.
Yeah. So it's going to be inverting common anode drive direct segment drive. For the demo board, set UIO 7.5 to 0.10. Okay, that's great. This is an example of great documentation, though, right? Because it tells me what I need to do. Yeah. Okay, but I can't do it with this. So let's try. Let's see if we can do this as a final demonstration of the REPL.
So load the project.
Yeah, so I'll search for the project first. tt.find dice shuttle. Was it one of those?
No, I think it's TTRPG. Yeah.
RPG dice by Jonas.
Oh, it is 105. It's right there.
Oh yeah, okay. All right. 105 dot enable. And when you do that, it is now actually clocking, right?
It is.
But on the commander, you have to set it to clock.
Yes.
Okay, so now I need to do UIO.
No. Well, yeah, the OE stuff.
Yeah. Well, I don't need to do that because OE is driven by the design, right?
It's no, but I thought we had to set UIO 7.5 to 0.10.
Yeah. Yeah.
So we have to write to it, right?
Yeah, but it's the ASIC that controls which direction they're going, right? We don't have any say about that.
Right, but we have to set our own bidirectional pins to write to it.
Okay.
So you can set that to, yeah. So if you do UIOE and tab that shit, yeah, it's 725010010. So tab, just yeah.
Pick them.
Just
Okay.
yeah, because we want to make it clear.
Yeah.
Now you should be able to do, what is it, 7 to 5?
Yeah.
7 5. Close that, equals OB111.
I think it was 010, wasn't it?
No. We're setting the direction now.
Ah, yeah. Output enable, so that
111.
so we're driving input.
Yeah. So enter that.
Okay.
And now UIO in 75010.
I much prefer this slicing and assignment that we have now.
Yeah, well, it's anyone who's happy with Verilog should be happy with
Okay, well the lights are all off.
Now what do we do?
Now we've got to it's also expecting a 2-digit. Press one of the buttons and release it. The dice roll is shown on the LED for about 8 seconds, so we can just toggle UI 0.
Okay, so let's do it. Yeah, UI in 0.
I don't see
Nothing.
anything. It is clocking, is it?
We can check. Oh, I meant through the through the SDK, but do you see it?
Yes.
It's that it's RTC/Quartz watch speed.
It won't be in reset either, will it?
It shouldn't be. We can check, but it shouldn't be.
Okay.
So yeah, 0.
Not seeing anything.
Can you just print out the UIOOE and the just you don't need to print it. You just need to put it on the command line. See the representation. Yeah. Tab. So that's set to what we want, right?
Yeah.
Okay, and the other one is also should be set to what we want. UIO in
58. Can we print that in binary style?
Yeah, just do dot value. Enter.
Cool.
Why is there an extra 1?
Well, those ones are going to be.
Oh, we're reading some, right? Okay.
Yeah, that's bits. That's these bits. These two, 1s digits and 10s digits common.
Input, output. Okay. Well, anyway, so it's the bits we want are set as we want, right? We said. Seven to 5010. 7 to 5010. I'm not sure that that's what it is. Is it?
010.
Okay. Well, inconclusive. What are we doing wrong?
We did enable it, didn't we? Yeah.
So you can check if it's actually. Oh, you did check if it was clocking. TT reset and.
It's because it's saying here that if without a common driver like the one on the demo board, if such a display is used, it will toggle between showing the first digit and blanking tens digit, which will look like a slightly wonky 0. Yeah, so I'm surprised. Think that this should be showing something now. Where is Jonas?
If on the REPL you just enter TT enter, what does it say? Auto clocking, yes, it's not in reset. Okay, I don't know.
Okay, yeah, inconclusive.
Inconclusive.
I can put a beginning of a test report together though.
C stream with lots of putzing and inconclusive results.
Yeah, that was it. Partially, no. Wasn't able to see anything on the demo board led after setting top bider to 010 and toggling an input pin. So hopefully we get some progress on that. Otherwise, it's time to call it a day because I've got something else starting now. Thanks, Pat, for joining and helping out with the putting you on the spot with the intense Cocotb translation.
Cool. We could have chosen a simpler example, but this one actually shows some real life. So that was good.
I'll leave it on overnight and we'll see if it gets to the end of its test.
Yeah, okay. I may actually work on trying to optimize it a little bit, but so far, yeah, your test has been the hardest one.
The longest one.
Time. Yeah.
Okay, yeah, and thanks everyone for tuning in. Leave me comments or whatever. Let me know in the Discord if you like this kind of stuff. My idea is to chop out some of the more interesting bits and then make a kind of highlights or video to help people get in the mood for when they're doing their own TT06 bring up and show some of the other projects on there. And if you didn't see this stream we did earlier, check that out. That's got some investigation into the analog projects and some other tests. So thanks for tuning in and see you around. Bye-bye.
Cheers.
End stream.